Thank you, Marcelo. Bom dia. That's as much Portuguese as I'm going to speak, I'm afraid. All right, so I want to extend my welcome to all of you at Autodesk University. I'm really excited to be back here in Brazil. I haven't been here for a while. It's always great to see all the changes I see, and it's always great to see this many people here. I remember when this event couldn't fill a room this size, so I'm really excited, and I hope you get a lot out of your visit here these next 2 days. Now, what I'm going to do is I'm going to spend some time possibly talking about a few things you already have heard, but I want to do it through the context of Autodesk and what we see really changing the way all of you work in the future, and some of the things we're doing to respond to that. And I want to start with a story about a company, and then I'll tell you why I'm starting with this particular story. And this company is a company called BAC, or Briggs Automotive Company. And what they're doing is they're building a custom car. And they're selling against Mercedes and other large manufacturers for this custom car market, this high-end custom car market. And it's just a couple of brothers that did this. And what they're doing is they're using new materials, new ways of making things, and they're going to market significantly faster. Now, the thing they compete against is still these large companies that have pretty complex processes for bringing a car to market. It still takes, despite the best efforts of large automotives, about 4 years to bring a new car to market, about 4 years. Now these guys started completely digitally. They didn't have big resources, they didn't have large design studios. They basically started doing everything in the computer. They used simulation, visualization. All these pictures I'm showing you are not real. These were all done prior to the car actually being built. And they were able to bring this car to market in about 2 years, less than 2 years. Right? Now this car, it's a beautiful car. It's a race car, but it's also street legal. So you can buy it, you can race it on a racetrack, but you could drive it down the street. Now, this isn't unusual. People have been making custom cars for a long time. What's unusual is that more and more companies are doing this in more and more industries. These little companies are doing things that really only big companies were able to do before. And that's pretty interesting. And I'm going to talk a little bit about why we think that's happening and what's driving it. And I'm going to do it under the context of the future of making things. And the reason it's important for all of you is this. One, if you're a small company, you've never had a better opportunity over the next 5 years to compete more effectively in the businesses you serve. If you're a big company, you've never had more small companies competing for the business you serve. And you have to pay attention to these trends and ask yourself, how am I going to embrace some of these trends so that I actually compete more effectively and I don't get my market taken away by somebody who's using all these trends to do really new and exciting things. Now, what are these trends? What are the things we're seeing? We see them in about 4 buckets. Right? We see big disruptions in design. I'm going to use the word disruption quite a bit. It's overused. Everybody uses the word disruption, but they are big disruptions. And they're happening over a 1, 2, 3, 4 year, 5 year period. So we see big disruptions in design, the way people are designing things. We see really big disruptions in the way people are producing things or the means of production. And I'll give you specifics about this. But what I want to say about this means of production is that the playing field, the ability to build something is getting leveled. It used to be only big companies could build complex things, but you'll see in a minute that over the next few years, little guys will be able to build incredibly complex products incredibly profitably. There's a changing nature of demand, and what I mean by demand is the customers you sell to, whether they're consumers or businesses or governments, what they expect from you is changing dramatically. And it's changing because of the nature of what products are in the future. And products can be anything. A product can be a building, a product can be a consumer device, it can be a piece of infrastructure. But the expectation about how that product works and how it evolves over time is really changing. And I'll get into each one of these trends. So let's start with design. Let's start talking about how design is changing and how new generations of designers and new technologies are going to affect design over the next few years. The first thing that's really affecting design is there's a whole new generation of engineers, designers, and customers that are very comfortable working in collaborative environments that are virtual, that come together suddenly to solve a problem and go apart. There's a whole generation of people that call somebody a friend they've never met face-to-face before. And that generation is completely comfortable with this new style of working. And it's this generation that's starting up a lot of these small companies. It's not the only one that's doing it. But this nature of collaborative work and coming together quickly to solve a problem and then go off and do something else is a dramatic change in the design paradigm. We as software vendors have to address this, but you as customers have to realize that this is becoming real. You're not just competing against the people down the street, you're competing against the people down the street and their ability to work with people all over the world to solve a really important design problem. The other big thing that's affecting design is the rise of cloud computing. Now what I want you to do is imagine for a minute if every single designer, architect, engineer, I don't care who they are, had a supercomputer sitting behind their computer screen. It was just sitting there behind their computer screen, and it cost them virtually nothing to use it. That's what's happening. It's getting cheaper and cheaper to use massive compute power, and companies like us and others are bringing that compute power to everybody's computer. What does that mean? How does that change the design process? So let me give you an example, one example of how it might change the design process. It's something we call generative design. Now, the idea of generative design is using the computer behind the scenes to help the designer make critical design decisions before they finalize what they're trying to accomplish. So in this case, you see the computer took some requirements about a building, shade requirements, all of these things, and gave the designer dozens and dozens of options. And the designer can go, okay, which one of these options that I might not have ever thought about are most interesting to me? And then they can drill in and actually figure out, okay, what do I want to do next with this design? So the computer, through the availability of massive computing power, can help facilitate the design process, help give you ideas. Sounds a little creepy, but it's going to happen. Now let me give you another example. This is a company called Lightning Motorcycles. So this is a fully electric motorcycle. It's super fast, right? It's also got to be super light because most of the weight is batteries. So we worked with this company to try to look at some of their design processes and help them look at ways of lightweighting things, making things lighter. Now, what I'm about to show you isn't necessarily what someone would actually do with a design, but it's a view into the future. So see that little rocker arm in the back that controls the rear tire? It has certain requirements. It has certain stress requirements, strength requirements. And what we did is we asked the computer to take a block of material and tell us what the lightest weight structure would look like. And this computer over time evolved the shape based on what the loads had to be and what the parameters had to be into something that the designer would have never thought of. Now, this might not be the designer's final design, but this absolutely represents the lightest weight, simplest design that can satisfy all the constraints and can be immediately 3D printed. Immediately. It's already designed to be 3D printed by a computer. Now, there's a couple interesting things about it, and I'll point them out in a minute. First thing I want to point out to you is that it's not symmetric. Now, the designer would have immediately created a symmetric thing, but on one side of the rocker is a chain, and the other side there isn't. So actually, the computer was smart enough to go, well, the chain's here. I have different strength requirements on this side than I have on this side. So like I said, this might not be the final design, but the designer now has a sense of, this is the lightest thing I can create. Now, what do I do with this? Now, another interesting thing about this, you might notice, if you're looking at this a little bit, it looks kind of organic. So there's the rocker arm that was designed by the computer, and what do you think those two things are there? You probably have some sense. One's a dog pelvis, and one's a cat pelvis. So it looks a lot like what nature came up with. And that's what you can do when you have massive amounts of compute power sitting behind everyone's computer screen. It's pretty amazing. You're going to see things like this happening. That means anybody can do incredibly complex things and do it well without having a supercomputer. right, so that's one. That was a little discussion about design. Let's talk about the means of production. And when I talk about the means of production, I'm going to talk about both the funding of production, how you get to that first thing, and how you actually build it, because that's changing quite dramatically. There's small changes now, but there's going to be big changes over the next 5 years. So in terms of how people actually get ready to build things, so this is an example from Brazil. This is Catarse. This is the Brazilian equivalent of Kickstarter in the United States. So what you can do with this is if you have a really good idea or a super bad idea, you can go out there and get somebody to give you money for it. And most of these sites work by getting people to pre-buy the product you're designing. So you pitch your product before you've actually built it, and people give you money for orders or maybe just out of the kindness of their heart as investors, and you use that money to build the product. Now, it used to be people would have to go find venture capitalists that thought their idea was interesting. You had to go through lots of procedures. It was really hard to get money. Now you can just go and pitch the idea to the world and see if people really want to give you money for it. Pretty interesting change. Lots of companies have started this way with these initial kind of things, just going out to the rest of the world and getting money. Now, the other thing that's changing is how people actually physically build things. And it's not just built products, it's buildings as well. So buildings. Buildings are starting to be built like machines. They're prefabricated off-site and assembled where they're built. That is a new trend in construction, and it's accelerating. Bits and pieces of the building are built ahead of time, and they're put together almost like an assembly line for building a car. You'll see it everywhere. The other thing you're seeing in the product design space is this rise of what we like to call fabless manufacturers. And what this means is that it's a manufacturer that makes a product, but they don't have any manufacturing facilities. Instead, what they do is they exploit what we call microfactories. And these microfactories can be anywhere. There's actually a company in San Francisco right now. This guy has got tons of venture capital. He's building a company that can deliver a factory that can be configured to build anything. It's filled with robots. It's filled with machines. And he says, tell me what you want to build, and I can configure this factory in a few days to build what you want to build. And it's just one building with a bunch of robots. This is happening everywhere, the rise of microfactories. And they're growing up locally and overseas. The other thing that's really important is the rise of 3D printing. 3D printing's been around for a while. It's not perfect, but it's going to change manufacturing dramatically. And I'm not talking about printing little plastic toys. There's lots of that going on, sometimes good, sometimes bad. I'm talking about printing metal, real parts. Now look at this strange thing. What is this? All right, this combines two of the trends I'm talking about, using the new methods of design and the new means of production. This is a heat exchanger that was designed completely by a computer and 3D printed in aluminum. So it was designed by a computer. We said, look, we got fluid coming in here. It's hot like this. We got fluid coming in here. We got a block of aluminum this big. Give me a heat exchanger that cools the fluid from this temperature to this temperature. This is what the computer came up with, and it was immediately 3D printed in metal. Now, you can't do that in production today. You can't do 100 parts a day like this, but you will be able to. Maybe not next year, maybe not the year after that. 5, 6 years, people will be doing this as a regular course of their business. This is going to change things dramatically. Now, it's not just, again, manufacturing. People are printing buildings. You see, these are houses that are 3D printed in concrete in China. They've got a big printer that goes and lays down the building, just like a 3D printer. Now, this is an ugly building. I get that. All right? But people are trying to figure out how to print and fabricate beautiful buildings. So here's the Museum of Modern Art in San Francisco. So this looks like it has this amazing limestone facade on the outside. It's gorgeous. It's not. All of that is fiber-reinforced plastic that was prefabricated before the building was built and assembled on site. Completely new ways of doing things. Somebody has even figured out how to 3D print a car. Now, I would not drive this car on a highway, especially a highway here in Sao Paulo. But someone's going to figure out how to print a car that you would drive on your highway. What is that going to do to the automotive industry when you can print an entire car chassis? Well, you don't need to weld it, you don't need to machine it, you don't need die machines, you don't need huge pressing machines. You just print your chassis and then roll it down the line and somebody turns it into a car. What is that going to do to the car industry? It's going to change everything. Everything. They also 3D print dresses. I don't know if this dress is comfortable. I don't know if I'd wear it or anyone I know would wear it. Well, I know I wouldn't wear it. But they're doing it. People are being creative and saying, wow, you know what? I can now 3D print a dress. It's fascinating stuff. It's happening everywhere. It's just the early stages. Now, this doesn't, for those of you who are big on manufacturing, this doesn't mean the end of classic subtractive manufacturing, milling, and things like that, all right? It doesn't mean the end of that. Subtractive manufacturing is getting smarter and smarter, and really you can only do things like this on subtractive machines, these really high precision things like blades for jet engines. But what's going to happen is, today we're like a 90% subtractive manufacturing world. Tomorrow, it's going to be much more mixed. It's going to be, I don't know, 50-50 subtractive and additive. Maybe even in some cases, 80 additive or 3D printing and 20% subtractive. Very different. And you can have one of these 3D printers down the street in a micro factory anywhere and send your stuff to it and get it built. Big changes in the means of production, really leveling the playing field, making it easier for anyone to compete with the big guys and making it easier for the big guys to do things they haven't done before, as long as they're paying attention. So now let's talk about the changing nature of demand, this growth in what people expect from what you build and what you provide to them. Now, to kind of start this, I'll talk about the tale of two generations. The generation on the right is the baby boomer generation. I can see most of you are not part of that generation. Some of you might be, maybe not out in the front. I am like basically the end of that generation. I'm like right at the very end of the baby boom generation. I call myself the generation nobody markets to. The baby boom generation was known as the me generation. It was me, it's all about me. And manufacturers, product development companies, infrastructure builders, developers, they made a lot of money off of building one thing over and over again for this generation. The new generation, we might as well call them the make it for me generation. They have a high expectation that something that's made for them is going to be customized to what their expectations are. They just expect it. And there's a couple of other things they expect. One, they actually care about how some of these things are made. Yeah, there's going to be lots of cheap plastic throwaway stuff in the world for a long time, but I'll tell you, lots of people are getting annoyed with cheap plastic throwaway stuff, and they're looking for things that last, and they're even willing to buy less of them, pay more for them, if it's going to last and it's going to be made for them. They care about where it comes from, they care about whether or not it's polluting, they care if it was made ethically, all of these things, and you know what? They'd also like to see it made where they live. This is happening all over the world. It's not just some kind of small minor trend. It's happening all over the world. People want things made for them. They want them made ethically, and they want them made where they live. Now, I'll give you an example of a company that combines almost all three of the trends I talked about earlier. They use the new methods of design, they use the new means of production, and they really are tapping into this new level of demand. So this company is a company called Normal. Now, here's what they do. They have a little iPhone app, so I'll tell you in a minute what these are. They're earbuds, obviously, okay? But they're custom-built earbuds. They have a little application you can put on your mobile device. You get the application, and you start your little procedure. And you hold the application up to your face, and it tells you what to do. And you do this, and you do this, and it takes pictures of your head. And then you have to hold a quarter on your head. It's kind of a little strange, but you have to hold a quarter on your head because it needs the coin for size reference. So you hold the coin on your head, and you do this, okay? And you send this all off to them. And a week later, they send you a pair of custom 3D printed, designed for you earbuds. It's a little boutique in New York. So they use your mobile device to capture your personal interests. They let you select your color. Then they 3D print it and send it to you. Yeah. Maybe you don't think this is useful, but people are buying this. Companies like this are the future. Big companies are doing this too. So a company, probably a well-known toy company called Mattel. How many people have heard of a Hot Wheel? Or were ever a kid and played with a Hot Wheel, okay? Well, guess what? You got to go to the store and buy your Hot Wheels. Now your kids, they can go online and say, I want my Hot Wheel to look like this, I want that, and they'll 3D print a Hot Wheel for a kid and send it to him. Okay, these are big changes. Big changes. All right? Here's an example here in Brazil. Okay? Fab Lab. So this is a environment where people can go in and make their own stuff. They can engage with 3D printers and design team. They actually use a lot of our new software, Fusion 360, for example. These guys are next generation. They're trying to help anybody build a design, build it to what they want, build it to their spec, and they're trying to facilitate this. They're partnering with educational institutions. They're turning into a nonprofit. They're doing lots of exciting things, and this is happening right here in Brazil. So it's not just something that's happening somewhere else. It's happening everywhere. So the last little piece I want to talk about, and then I'll start talking about what Autodesk is doing to respond to some of these things, is this notion of product. The whole idea of what a product is, what people expect from a product is changing. And there's a couple of things that are driving that. One of them is connectivity, but there's other things as well. This idea that when I buy a product, it doesn't get worse over time. I buy a product and it keeps getting better over time. Think about it. Aren't you starting to have this expectation that when you buy a product, it gets improved? Think about some of the new products you have. Do they get better over time, or do they get worse over time and then you throw them away? Now, this applies to everything. It applies to infrastructure, for instance. How many people use Google Maps? Okay. Yeah, everybody uses Google Maps. Okay. Google Maps tells you where the traffic is. It gives you an estimate of how long it's going to take you to get somewhere. Because basically, it's listening in on your cell phone saying, okay, this car's over here, it's taking it this long to get from here to here, and it's using that information to give you information about where you're going. When people design infrastructure in the future, there's going to be just an assumption that every vehicle or perhaps pedestrian moving through that infrastructure is going to be connected in some way. So today, when people design streets and roads, they design it to be kind of static. The lights turn on and off at a certain schedule, but what if the traffic lights adapted to the traffic flow patterns that were actually going through the street? So the whole system was designed to adapt to actually what's happening. What would happen? Would it work more efficiently? Would you move cars more effectively? Would the lights go faster in one direction because there's nobody coming the other direction? Think about it. That's the future of infrastructure design. The assumption is going to be that everything that moves through the infrastructure is somehow connected. Now here's one of my, I don't know if it's my favorite, I think it's one of my funniest, the connected kitchen. Now I don't know if this is important. I don't know if you need your dishwasher to talk to the internet. However, there are products out there that allow you to turn on your dishwasher when you're not home, warm up the oven before you get home, and talk to your kitchen. I even have a friend who has an egg tray in his refrigerator that tells him when it's time to go and buy eggs. Maybe you don't think that's useful. Personally, I'm not so sure, but a lot of people do. And this is just going to happen. These products are going to have this expectation that somehow on my mobile device, I can interact with my product so I can get instant gratification that the oven will be at 350 degrees when I get home. This whole notion of your house being instrumented. People know about Nest and other things like that, but Samsung recently bought a company called SmartThings that basically allows anybody to create a palette of connected devices in their home, and they can turn any kind of simple device into a connected device, and you can look at every device in your house. These sensors are getting cheaper and cheaper, and they're just ending up everywhere. Your whole entire house, certainly new construction, is going to be completely instrumented. You'll be able to control it while you're there, when you're not there. It's happening. It's happening right now. What does that do for people's expectations about what kind of services and product you deliver in the future? It changes everything dramatically. Here's another example of a fully connected product. Okay, so this is a company called Scully. They're making lots of new cars have really exciting displays that tell the driver everything about it, beautiful heads-up displays. These guys said, why can't motorcycle riders have a Wi-Fi connected, Bluetooth enabled, heads-up display, control everything while you're riding your motorcycle? That's what this is. It's a connected device with a heads-up display that helps the customer interact more. Pretty interesting. Now, in media and entertainment, if you don't think media and entertainment has these same kind of trends, it does. This integration between connected hardware and software and the user experience is dominating the game environment. It's going to dominate moving environments. Not only now is your teenager going to be playing a game and not talking to you, they're not even going to be able to see you. They're going to be sitting there in their own little world. Now, I don't know if that's good, but it's happening. And it's the new expectation. So these big disruptions, these are accelerating, they're happening, they're everywhere, and they're going to affect everybody's business. And they're around design, the means of production, demand, and the definition of a product. And we're seeing this in every single industry that we deliver solutions to. It's not just the product manufacturers, it's infrastructure, it's buildings, and it's media and entertainment. And that's basically what we call the future of making things. And some of the things we're seeing and we're trying to build new products and new capabilities for our customers for. Now, so I'm going to change gears now, and I'm going to talk a little bit about what Autodesk is doing to respond to these challenges and to exploit some of the new technologies that are out there to help you guys design more effectively and more better in this new brave future. So one of the first things we're doing, I think this is important, and I'll start at the beginning, is we're focusing a lot on the next generation. Now, why are we doing that? There's a couple of reasons why we're doing this. One, that particular kid right there may not become a designer in the future, they may not become an engineer, but they will be somebody's customer in the future. And we want to make sure that every one of this next generation are either ready to compete in the new future of making things, or they're ready to be a customer in the new future of making things. So when we look at education institutions, we don't look at education institutions as a business. We give everything we own, everything we have, free to educational institutions. Everything. We don't make a dime. All of our software, I don't care if it's our cheapest software or our most expensive software, they just get the software. Other people have a different strategy. Our approach is the next generation should have access to this for free. When they become professionals, they can pay for it. But now, let them have it. The other thing we're doing, and I get a lot of questions about this, is we've got a line of applications that are targeted at the everybody. Tinkerers, makers, hobbyists, kids, housewives. Why do we have these applications? One of the reasons we have these applications is we're trying to create a 3D literate consumer class. Because if you believe me that customers are going to expect things to be made for them, and the manufacturers of the future and the product developers of the future who exploit this are going to have the most profit and success in the future, then you want every consumer or business you interact with to be able to communicate with you in 3D. And that's what these tools do. It teaches the basics of 3D to everyone. Everyone will know how to communicate with a 3D design. Now, if you look at some of the things we're doing in product to address the New World Order, I'm going to give one example. I'm going to talk about Fusion 360. Now, this is a product development product. And it's actually a product development system, and it's a cloud-based environment. And the cloud's great for a bunch of things. The cloud's great for enabling collaboration, it's great for compute power, and it's great to make it all seamless and easy for someone to use. It's just really easy to deploy and do amazing things with really distributed groups in the cloud. So Fusion's, that car I showed you earlier, the Mono, can be designed in Fusion. You can design it, you can engineer it, you can fabricate it. Fusion has integrated capabilities to go to subtractive and additive printers. It's all right there inside of one design environment, and you can manage it all in the cloud. So you don't have to set up some kind of complex management system. It's all managed for you in the cloud. You can use the power of the cloud to do really complex simulation. You don't need to have a powerful computer. You can use a really simple computer and do complex simulations. You can use Fusion on any device. You can use it on a desktop, on a laptop, on a desktop, on a mobile device. on a tablet. It's built for the new future, the connected future that everybody's working in. And just like everything else we do, it's free to all the students, but also what we've done with Fusion is we've made it free to these guys, to startups. Because we think this is the way startups should be working. They can get it for free. When they turn into real companies, they only have to pay us $300 a year. That's the kind of things we're rolling out now. Now you may say, wow, that's a big change from what we've done before, both product-wise and price-wise. You bet. But we think the future is so incredible, we think the future is so bright and so big, we can do this, and we should be doing it. Now, the other thing we're doing, I talked about the new means of production, and I talked about the rise of 3D printing and how important I think 3D printing is going to be in the future. So we're not trying to watch this, we're trying to be an active participant. So how many people have heard about the Ember printer that we built? Anybody heard about this? Okay, so we actually built a 3D printer. Now, and it's on this Spark platform, and I'll talk a little bit about that in a minute. We're not trying to be a 3D printing company. If you remember what Google did when they first rolled out Android, they built a phone to help them develop Android, get it out there, and really perfect it and stimulate the growth of Android. They're not really much of a phone company anymore, are they? Samsung sells Android. Everybody else sells Android devices. But Google started by building a reference device. And what we're doing with Ember is we're targeting jewelry makers and those types of users. But we're actually trying to develop our Spark platform that makes it seamless to go from a design application straight to a 3D printer. Because right now, 3D printing doesn't always work all that great. What we're trying to do is make sure it works really great for everybody. And we even put some money behind it. We created a big fund called the Spark Fund, $100 million that we invest in companies that are trying to help us build this ecosystem of 3D printing, solve the connection problem to design applications, solve the material problems, solve the problems that customers care about so this ecosystem thrives. And here's an example of one of the companies we invested in. This is Carbon 3D. They've got a novel method that's fast, reliable, simple for printing. I mean, this is almost, it's weird, isn't it? The way it's just kind of pulling the 3D printed thing out of the liquid. So we've invested in these guys. These are another example of how 3D printing is going to accelerate over the years. It's just one example, but we're really interested in helping to be a part of all of this. So what we're doing, really, as a software company, is we're trying to create the ecosystem for the new future of how things are made. It's going to take us a while, but we're doing it at every end. We're doing it from the students and the hobbyists, the people who are the consumers of the future. We're doing it for startups and current professionals. We're trying to show them, look, you've got to start working this way. We're trying to catalyze the new means of production because we think when the means of production are leveled so that anybody can have access to how things are built, we're going to see an explosion of innovation. Because if everybody can build something, the only thing you can compete on is the power of your idea, not the amount of money you have to be able to build it. That's also why we're moving a lot of our applications to subscription. I know people have mixed feelings about that in some cases, but I'll tell you, people have never been able to get access to the kind of powerful software we have today at the kind of prices we're going to be delivering. It's really, over a multi-year period, going to change the way people get access to incredibly powerful tools. And that's a big force that we're trying to catalyze. And that's how we're going to make sure the future of making things is not only a brighter future for all of you, but that it's a more exciting future for all of us. So thank you very much. I really appreciate your time and energy, and I'm really glad I was here.